All right, so lesson 6-5 is equivalent algebraic expressions. You're going to write down this vocabulary, which is equivalent, the definitions for equivalent expressions. Those are expressions that have the same value. The expression will be equal no matter what value is submitted for the variable or variables. All right, so what this means is if we simplify the expressions, we can make them look the same. Okay, that's how we can determine if we have algebraic expressions. Also, we can take a number and substitute it into the expression, both expressions, and if we come out with the same value, then they are equivalent. Now, the problem with doing a substitution is you can't just substitute once and say, oh yes, equal. You have to substitute several values for the variables, then determine if it's equivalent or not. That's why simplifying is the best way to do it. Okay? All right, so example 1 is equivalent algebraic expressions, and we want to determine if the expressions are equivalent. So we're going to simplify both and then compare. So now the first one, 10n minus 4, of course, there's no parentheses, no like terms. We know that's simplified, right? For the second one, we've got parentheses, and we have some like terms floating around in there. So we know this needs to be simplified. So what am I going to do first? I need to get rid of the parentheses using the distributive property. Very good. So we've got 3, positive 3 times positive 2 is positive 6. And positive 3 times positive 5n is positive 15n. And then we've got minus 5n minus 2. And now we can identify our like terms and combine. So we've got a positive 15n here and a negative 5n there. What does that give me?
Positive 10n.
Positive 10n. So far, so good. Then I've got a positive 6 over here and a negative 2 over there. What does that give me?
Positive 4.
Positive 4. So are these equivalent expressions?
Yes.
Are they?
No.
No, they are not. Because look, this says minus, this one says plus. So these are not equivalent. So your answer is not equivalent. Is everybody clear what we just did? So we know this one's simplified. We had to simplify the second expression. And then once we have them both simplified, then we can compare. And then when we compare, we decided this is not equivalent. Take 2 minutes and do example B with your table partners. For example B, we have negative 3 times the quantity x plus 4 minus 2x and negative 5x minus 12. So we know that the second expression is simplified, right? So we want to simplify the first expression. So again, we're going to use the distributive property. So we've got negative 3 times x is negative 3x. And then negative 3 times positive 4 is negative 12. Very good. And then minus 2x. So now we can identify our like terms. So we've got a negative 3x. We've got a negative 2x. So what's negative 3x plus a negative 2x?
Negative 5x.
Negative 5x. And then we bring down minus 12. So now we compare. Are they equivalent?
Yes.
Yes. So yes, equivalent. Very good. All right. So again, an expression can be simplified when there are like terms in the expression. So here we've got like terms. We've got some constants that we could put together. Over here we've got constants and variables. So that means on both of these, and there's parentheses, right? So on both of these, we need to simplify both of those expressions and then compare. Okay? So the first thing we want to do, for example A, is use our distributive property. So we'll use that distributive property. So 2 times negative 4y is negative 8y. And then positive 2 times positive 3 is, what? Positive times a positive is a positive. So that's positive 6. And then minus 9. Okay? So what can I combine in the first example, in the first expression?
Positive 6 and negative 9.
Positive 6 and negative 9. So the negative 8y, we can't combine that with anything, so we're just going to bring that down. So negative 8y. Then we've got a positive 6 plus a negative 9, which gives us a
Negative 3.
very good, negative 3. Now, we still, at this point, we cannot compare yet because we still have to simplify the second one, right? So what do I do first with the second one? What?
Distribute a 1.
We need to distribute. So here we've got a positive 1 over here. Right, we've got a positive 1 here, and we've got a negative 1 over here. Now, if I am distributing a positive 1, do I have to do any calculations? No, you just take away the parentheses, right? So we're going to rewrite. So we have y plus 3. And now we're going to distribute the negative 1. And remember, we talked about keep, change, right? That just means that everything, when you multiply times a negative 1, everything in the parentheses becomes the opposite. Okay? So here, this positive 6 becomes a negative 6, and this positive 9y becomes a negative 9y. And now we can combine our like terms. So here, this one is a positive y, positive 1y, plus a negative 9y. What's that going to give me?
Negative 9y.
Negative 1 minus 9 is
8y.
negative 8y. Very good. So this is going to be a negative 8y. And then we've got a positive 3 and a negative 6. When we combine those, what do I get?
Negative 3.
Negative 3. And so now we compare, and of course we have equivalent. Very good. So yes, these are equivalent. Yes. So the first thing we need to do here, we've got 4 times the quantity, negative 2x plus 3 plus 3x minus 2, and we've got the quantity 2x plus 1 minus the quantity 3 minus 2x. Now, normally when you see parentheses, you would say, oh, we need to do the distributive property, right? But do you notice anything inside those parentheses?
There's a lot of numbers.
We can do some combining of like terms. Very good. So here we've got a negative 2x and we've got a positive 3x. We've got a positive 3 and a negative 2. So now we can combine those like terms. Okay? So we've got 4 times a quantity. Let's see. Negative 2x plus 3x is what? Negative 2x. Listen to what I'm saying. Negative 2x plus 3x. Positive 1x, which we can just write x. And then I have 3 minus 2, which is positive 1. Is everybody with me? All right, let's simplify this next one. So here, the first thing we can do is the distributive properties. Now, again, we're distributing a positive 1 on the first expression and a negative 1 on the second one. So, for the first expression, we just have to take away the parentheses. So that's going to be 2x plus 1. And then over here, when I use my distributive property, or do the keep, change, change, everything inside the parentheses becomes the opposite. So this positive 3 is going to become a negative 3, and the negative 2x is going to become a positive 2x. So now we're going to combine our like terms. So we've got a 2x here and a positive 2x there. What's that going to give me? 4x. And then we've got a positive 1 and a negative 3, which gives me a negative 2, right? So now over here I need to do some distributing. So here 4 times x is 4x, and then 4 times positive 1 is positive 4. So do I have equivalent expressions? No. Why? Right. This is a positive 4. This is a negative 2. So these are not equivalent. Is everybody clear?